Hello everyone. In this video, I am going to discuss about solution of non-homogeneous linear differential equations with constant coefficients when Q is of the form x power m or polynomial in x. How to find the general solution of non-homogeneous linear DE with constant coefficients? The general solution of non-homogeneous DE is given by y equals to complementary function plus particular integral. In my earlier video, we were discussed about how to find complementary function. Now today we are going to discuss about how to find particular integral when q is a polynomial in x. When q is a polynomial in x, now this is the procedure to find a particular integral. When q is x power m or polynomial in x, or polynomial in x, the method says that now pi is equals to 1 by f of d into q, where q is a polynomial in x or x power m is a positive integer. Now in this case, we take out least degree term outside from f of d and we express this f of d in the form 1 plus or minus some function of d. By taking a least degree term outside from f of d, we express f of d in the form 1 plus or minus f of d, some function of d. Now here, make using these formulae 1 minus x whole power minus 1, 1 plus x whole power minus 1, 1 minus x whole power minus 2, 1 plus x whole power minus 2. Make use of one of these formulas and express this 1 plus some function of d in terms of d. Then we will try to find particular integral when q is x power m. Now what is this formula? 1 minus x whole power minus 1. The formula is 1 plus x square and so on. In this case 1 minus x plus x square minus x cube and so on. In this case 1 plus 2x plus 3x square and so on. In this case 1 minus 2x plus 3x square and so on. If it is 1 minus x whole power minus 1, we will get all plus terms, plus signs. If it is 1 plus x whole power minus 1, we get alternatively plus minus signs. 1 minus x whole power minus 2, we get all plus signs. 1 plus x whole power minus 2, we get alternatively plus minus signs. Now this is the method to find particular integral when q is a polynomial in x. Now let us discuss some examples. Solve d square y by dx square plus dy by dx equals to x square plus 2x plus 3. Now this is the given problem. Now clearly it is a linear differential equation with constant coefficients and q of x is a polynomial in x. Now let us discuss how to find solution of this one. To find general solution of this problem, first we need to find complementary function of this one by considering right hand part as 0. First let us find complementary function of this problem. Now first I'll write what is the given problem. Now this is the given problem. D square y by dx square plus dy by dx equals to x square plus 2x plus. This is the given problem. Now first write the given problem in operator form. One can be written in operator form. One can be written as like this, d square plus d into y equals to x square plus 2x plus 3. Now here d is nothing but differential operator. D is called differential operator. D is nothing but d by dx. D square is nothing but d square by dx square. Now this is nothing but f of d into y equals to q of x, where f of d is nothing but d square plus d and q of x is nothing but x square plus 2x plus 3. Now let us find a complementary function of this problem. To find complementary function of this one, we consider right hand part as 0. Now we write auxiliary equation. Now let us write a auxiliary equation of this problem. Auxiliary equation is given by f of m equals to 0, that is m square plus m equals 0. By solving this quadratic equation, we get 0 and minus 1 as roots of this auxiliary equation. Clearly these two roots are real and distinct. So complementary function is given by c1 into e power first root plus c2 into e power second root. Now this is nothing but c1 plus c2 e power minus x, where c1 and c2 are arbitrary constants. Now this is a complementary function of this problem. Now let us discuss particular integral of this problem. Now particular integral is given by pi equals to 1 by f of d into q. In this case, f of d is nothing but d square plus d and q is nothing but x square plus 2x plus 3. Now clearly here q is a polynomial in x. So to find a particular integral of this problem, we use the method discussed just now. In this case, method says that now take out the least degree term from f of d outside. In this case, the least degree term is d. Now here we have d square and d power 1. Now d power 1 is the least degree term. So we write d power 1 outside. By taking d power 1 outside, d outside, we get 1 plus d square by d, that is d, into q, x square plus 2x plus 3. Now let us take this 1 plus d to the numerator. We can write like this, x square plus 2x plus 3. Now using this formula, 1 plus x whole power minus 1, this formula is 1 minus x plus x square minus x cube and so on. This is the formula. Make use of this formula here. Now clearly here q is a polynomial of degree 2. So if you write the formula up to second degree term, because d square of x square gives a constant. Now d cube of x square is always 0. Now d power 4 of x square is always 0. Now d power n plus 1 of x square is always 0. Now it is a polynomial of degree 2. So if you write up to second degree term, that is enough, because d square of x square is constant, d power 3 of x square is 0 and d power 4 of x square is 0 and so on. So we can neglect all these terms. We can write up to second degree term. So this can be expanded like this, 1 by d, 1 minus d plus d square. We can write up to this term, because as we discussed here, d cube of x square and so on are zeros, into x square plus 2x plus 3. Now let us simplify this one. This is 1 by d times this into this one, that gives x square plus 2x plus 3 minus d times x square plus 2x plus 3 plus d square times x square plus 2x plus 3. Now let us simplify this one. 1 by d times x square plus 2x plus 3. D means differential operator. D means differential operator. D is nothing but a differential operator. Differential operator. D means derivative, differential operator. So d of x square is simply 2x. Now d of x is simply 1. Now d of any constant is 0. So here d of x square is 2x plus d of x is 1 here. So here 2 is constant, d of 3 is 0. Now plus d square of x square is 2. This is 0 and this is 0. Let us simplify further. 1 by d times x square plus 2x plus 3 minus 2x minus 2 plus 2. Here plus 2 minus 2 can be cancelled, minus 2x plus 2x can be cancelled. So we get like this. After simplification we get like this: 1 by d times x square plus 3. Now 1 by d means inverse operator, integral operator. 1 by d means we can say inverse operator or integral operator. 1 by d means integration of x square. What is integration of x square? Integration of x square is x cube by 3. So let us write here, we get x cube by 3 plus 3x. Now this gives particular integral of the given problem. Now required solution is complementary function plus particular integral. Now what is the complementary function in this case? In this case complementary function is given by c1 plus c2x, c2 into e power minus x. Let us write that. Now complementary function plus particular integral. Now required solution is of 1 is given by complementary function plus particular integral c1 plus c2 e power minus x plus particular integral is x cube by 3 plus 3x. Now this gives the required solution of the problem, where c1 and c2 are arbitrary constants. This is the required solution of the problem. Now let us discuss another example. 1. Solve this is the next problem. Solve d square minus 4d plus 4 into y equals x cube plus 1. Now clearly the given problem is a linear differential equation with constant coefficients. This is readily given in operator form. Let us find solution of this one. To find solution of this one, first we find complementary function. Now this is the given problem. This is readily in operator form. So this is f of d. One can be written as like this: f of d into y equals to q of x, where f of d is nothing but d square minus 4d plus 4. This is nothing but we can write d minus 2 whole square. And what is q here? Q is x cube plus 1. It is a polynomial in x. Let us find complementary function. To find complementary function, we write auxiliary equation. Auxiliary equation is given by f of m equals 0, that is m minus 2 whole square equals 0. By solving this, we get m equals to 2 and 2. Now clearly the roots are realigned, repeated. Now in this case, complementary function is given by c1 plus c2x e power 2x, where c1 and c2 are arbitrary constants. Now let us discuss how to find particular integral. Now in this case, particular integral is given by pi equals to 1 by f of d into q. Here f of d is d minus 2 whole square. Q is x cube plus 1. Now let us write a least degree term outside from this term. Now in this case, constant term is a least degree term. So let us write constant outside. By writing constant outside, we get a 2 square, that is 4. I am writing minus 2 outside. So we get like this. Let us simplify this one further. Let us simplify this one. 1 by 4 times, by taking this numerator, 1 minus d by 2 whole power minus 2 into x cube 1, x cube plus 1. Now make use of this formula, 1 minus x whole power minus 2 formula. The formula says that 1 plus 2x plus 3x square and so on. Here it is a polynomial of degree 3. So we write up to d cube term. So this can be written as 1 by 4 times 1 plus d by 2 plus d by 2 whole square, 1 plus 2 into x plus 3 into d square plus 4 into d cube. Okay, we can write up to this term because it is a polynomial of degree 3. So degree 4 derivative of d power 4 of x cube is 0. So we can neglect all the terms. Now try to simplify this one further. If we simplify this one, 1 by 4 times 1 plus d we get plus 3 times d square by 4 plus 4 d cube by 8 we get x cube plus 1. Now let us simplify this one. 1 by 4 times x cube plus 1 plus d times of x cube plus 1, 3 by 4 times d square of x cube plus 1 plus 4 by 8 times d cube of x cube plus 1. Let us simplify this one. If you simplify this one, we get like this. 1 by 4 times x cube plus 1. D of x cube is 3x square. Derivative of x cube is 3x square. Derivative of 1 is 0 plus 3 by 4 times. Derivative of x cube is 3x square. Do one more time. We get 6x. I am writing like this. D square of x cube. This is nothing but d of x cube. D of derivative of x cube is 3x square. Then derivative of x square is 2x. So we get here 6x. I am writing d square of x cube as 6x plus derivative of a constant is 0 plus d cube of x cube. Do one more time. Derivative of this one we get 6 plus 0. Now simplify further. We get 1 by 4 times x cube plus 1 plus 3x square plus this is 2 can be cancelled here. 2 2s are 2 3s are, so 9 by 2 x plus 3. Now this is the particular integral of the problem. Now required solution is given by complementary function plus particular integral. Now what is the complementary function in this case? The complementary function is c1 plus c2x e power 2x. So required solution is given by required general solution of 1 is given by complementary function plus particular integral. Complementary function is c1 plus c2x into e power 2x. Particular integral is 1 by 4 times x cube plus 3x square plus 9 by 2 times x plus 4, where c1 and c2 are arbitrary constants. This gives the required general solution of the problem. Thank you.